Earth is 4.5 billion years old. That number is easy to say and almost impossible to actually feel, because nothing in a human life is built on that scale. If you tried to walk that timeline out at a comfortable pace, one step per year, you'd need to circle the entire planet more than 100 times before you reach today. So let's try to make it feel real a different way, by walking through the whole story from the beginning, in order, the way it actually happened. Before there was an Earth at all, there was just a vast, slowly spinning disk of gas and dust surrounding a newborn sun. Gravity did the rest. Dust clumped into pebbles. Pebbles collided into boulders. Boulders merged into small worlds. And small worlds kept colliding and combining until, out of pure chaotic accumulation, a handful of planets emerged, Earth among them. It formed, roughly, out of sheer repeated impact, which turns out to be a fitting way to begin, because the violence didn't stop once the planet technically existed. It starts in violence. Right after Earth formed, it wasn't a planet you'd recognize. It was a churning ball of molten rock, its surface an ocean of lava under a thick, choking atmosphere made mostly of carbon dioxide. Early in this chaos, something enormous slammed into it, a Mars-sized body that scientists call Theia. The collision was so powerful, it blasted a huge amount of material into orbit, and that debris eventually pulled itself together into a single glowing companion, the Moon. Right after the impact, the Moon hung enormous in the sky, far closer than it is now, and it has been slowly drifting away, a little further every year for 4.5 billion years since. This earliest chapter is called the Hadean, named after the Greek god of the underworld, and the name fits. For hundreds of millions of years afterward, the inner solar system was still a chaotic, unfinished place, and Earth and its neighbors endured a long, punishing stretch of asteroid and comet impacts that scientists call the Late Heavy Bombardment. Look up at the Moon's cratered face today, largely unchanged for billions of years with no wind or water to erode it, and you're looking at a fossilized record of exactly how violent this period really was. A reminder that becoming a stable planet wasn't a single event, it was a demolition derby that lasted an almost incomprehensible amount of time. Almost nothing from this period survives to be studied directly. The planet has resurfaced itself so many times since that the physical evidence is nearly gone. What little we do have comes from tiny, almost indestructible crystals called zircons, and they hint at something surprising, that liquid water may have existed on Earth's surface far earlier than anyone expected, even while the rest of the planet was still being pummeled from space. Slowly, unbearably slowly, by any human measure, the bombardment eased, and the planet cooled. Oceans formed, and somewhere in that early water, chemistry crossed a line it can't uncross. Life appeared. Exactly how remains one of the biggest open questions in science. Leading ideas point to chemical reactions in shallow tide pools, or around scalding hydrothermal vents on the ocean floor, where simple molecules could have slowly assembled into something capable of copying itself. However it happened, by roughly 3.5 billion years ago, the first simple, single-celled organisms were already here, quietly existing in a world with no oxygen to breathe and no other life to compete with. Then came one of the most consequential events in the planet's entire history, and it happened slowly enough that nothing alive at the time could have noticed. Some early microorganisms evolved the ability to photosynthesize, pulling in sunlight and carbon dioxide and releasing a strange, chemically volatile gas as a byproduct, oxygen. For hundreds of millions of years, oxygen was actually a poison to most existing life, and its slow buildup in the atmosphere eventually triggered what scientists sometimes call the Great Oxidation Event, one of the largest extinctions in Earth's history, long before anything with a face or a name would exist to be extinct. But it also set the stage for everything that came after. An oxygen-rich world is the only kind of world that could ever produce animals like us. Around 3.2 billion years ago, in an era called the Mesoarchean, something else new began. Continents. Chunks of solid crust, thick and buoyant enough to rise above the ocean and stay there, started to form and drift, the first real land in Earth's history. It would still be an almost unimaginably long time before anything walked on it. Roughly 2 billion years ago, life took another quiet, radical turn. In what may be one of the strangest events in evolutionary history, one simple cell appears to have engulfed another, and instead of digesting it, kept it alive inside itself, forming a partnership neither organism could have managed alone. That captured cell eventually became the mitochondria, the tiny energy-generating structures found inside almost every complex cell on Earth today, including every cell in your body. It's the reason biologists sometimes only half-jokingly call this the most successful merger in the history of life. From that point on, cells could be bigger, do more, and eventually cooperate closely enough to become multicellular organisms. For an enormous stretch of time after that, evolution still moved at a pace that's hard to comprehend. Life stayed mostly simple and entirely confined to water, generation after generation, for well over 1 billion years. It's one of the strangest facts about our planet's history. Complex life took vastly longer to get started than it did to go from the first fish to us. Around 720 million years ago, the planet went through one of its most extreme climate swings ever recorded. A series of glaciations severe enough that, according to one major hypothesis, the entire globe may have frozen over almost pole to pole, an event nicknamed Snowball Earth. When the ice finally retreated, tens of millions of years later, it may have left behind a world so chemically disrupted that it helped set the stage for one of evolution's great leaps forward. Around 571 million years ago, in the Ediacaran period, the fossil record shows something genuinely new: soft, strange, often disc or frond-shaped organisms unlike anything alive today. The first confirmed complex multicellular life, quietly experimenting with being large before anyone had figured out shells, legs, or eyes. Then, around 539 million years ago, everything changed almost at once in an event called the Cambrian explosion. In a geological instant, a few tens of millions of years, which sounds long until you compare it to the previous 3 billion, life diversified explosively. Hard shells, complex eyes, legs, the first real predators and prey. Nearly every major body plan that exists in animals today has its roots in this one relatively short window. The oceans kept innovating from there, though not without setbacks. Around 444 million years ago, a sudden, severe ice age dropped sea levels dramatically and triggered the second worst mass extinction Earth has ever experienced, wiping out a large share of ocean life in 2 brutal pulses before the recovery continued. By the Devonian period, roughly 419 to 359 million years ago, the oceans had become what paleontologists sometimes call the age of fishes. Armored placoderms with bony plated heads, early sharks, and increasingly complex jawed predators filled the water in enormous variety, some growing to be among the largest predators the planet had ever seen. On land, plants had finally gained a real foothold, growing tall enough and dense enough to form Earth's first true forests, and insects had begun exploring the air and undergrowth in some of the earliest known terrestrial ecosystems. And somewhere in the shallows, a few ambitious fish began experimenting with the unthinkable, using primitive limb-like fins to drag themselves onto shore, becoming the first vertebrates to ever stand on solid ground. By around 359 million years ago, in the Carboniferous period, those early forests had grown into vast, humid swamps and jungles, so productive that when they died and were buried, they eventually compressed into the coal seams humanity still burns for warmth and electricity today. Meaning some of the energy powering the modern world is, quite literally, hundreds of millions of years of stored sunlight. Around 299 million years ago, in the Permian period, all of Earth's land masses had drifted together into a single vast supercontinent called Pangaea, the last time in the planet's history that all the world's continents would be one. It didn't last. A few tens of millions of years later, in what may have started as a series of massive volcanic eruptions in what's now Siberia, lava and gas poured out over an area roughly the size of a continent for an extended period, devastating the global climate and triggering the most catastrophic extinction event Earth has ever experienced. The overwhelming majority of all species alive at the time, by some estimates, well over 90% of ocean species alone, were wiped out. Scientists sometimes call it the Great Dying, and if it hadn't happened, the world that came after it might be unrecognizable. But life recovered, as it always has. Around 252 million years ago, the Triassic period began, and in the wreckage of the Permian extinction, a new kind of animal quietly emerged, the dinosaurs, sharing the recovering world with early mammal-like ancestors of our own. The dinosaurs didn't win immediately. For tens of millions of years, they remained a relatively minor presence. Then, around 101 million years ago, another sharp mass extinction swept through at the end of the Triassic, and when the dust settled, it was the dinosaurs, not their rivals, who inherited the empty ecological space. What followed is the stretch of Earth's history most people actually picture when they imagine the deep past, the age of reptiles, dinosaurs of every size and shape spreading across every continent. While off to the side, almost unnoticed, one branch of small feathered dinosaurs was slowly becoming something else entirely. The ancestors of every bird alive today. The world the later dinosaurs lived in would still look strange to us in one particular way. For most of the age of reptiles, the landscape was dominated by ferns, conifers, and cycads, without a single flower anywhere on the planet. That changed sometime in the Cretaceous period, when flowering plants, angiosperms, appeared and then spread with startling speed, transforming forests, enabling entirely new relationships with pollinating insects, and eventually reshaping what much of the land on Earth actually looked like. By the very end of the dinosaur era, a world with color, with blossoms, with fruit, finally existed. For well over 150 million years, the dinosaurs were the dominant story of life on Earth. Vastly longer than mammals have existed, vastly longer than anything resembling a human. And then, in a single catastrophic afternoon, around 66 million years ago, an asteroid, roughly the size of a small city, struck what's now the Yucatan Peninsula in Mexico, punching a crater more than 100 miles wide and triggering firestorms, tsunamis, and a global blackout of dust and debris that blocked sunlight for years. The age of dinosaurs ended almost as abruptly as it began. Most species on Earth, not just dinosaurs, were wiped out. In the aftermath, the world quietly reorganized itself. By around 66 to 23 million years ago, in the Paleogene period, the continents had drifted into roughly the shapes we'd recognize on a map today. And with the dinosaurs gone, a group of small, unremarkable mammals that had been living in their shadow for 100 million years finally had room to spread out, diversify, and grow. It was, in a very real sense, finally our time. Even so, our time arrived slowly. Mammals spent millions of years diversifying quietly before anything resembling a primate showed up, and the planet cycled through repeated ice ages over the last few million years, vast sheets of ice advancing and retreating across entire continents, reshaping landscapes long before anyone was around to notice. Somewhere within that icy, unstable backdrop, in Africa, a new kind of primate emerged. One that walked upright, then made tools, then controlled fire, then developed language. Several different human-like species overlapped and coexisted for long stretches, migrating out of Africa in repeated waves, adapting to Ice Age tundra, dense forest, and coastline alike. Homo sapiens, our own species, has existed for only around 300,000 years, meaning that even within the story of us, almost all of it happened before anyone wrote anything down. Agriculture, permanent settlements, cities, and writing are younger still, appearing only in the last several thousand years, a final, vanishingly thin layer on top of everything that came before. And so, if you were still watching the whole 4.5 billion year story unfold at a steady pace, you would need to be paying very close attention indeed, because you'd almost miss what happens next. All of recorded human history, every civilization, every war, every book ever written, every single thing anyone has ever built takes up a sliver of time so thin it barely registers against everything that came before it. Earth is ancient. We are new. Almost impossibly new. The continents are still drifting, a few centimeters a year, exactly as they have been this whole time, and they'll keep rearranging themselves long after we're gone. And maybe that's the actual point of walking through the whole story in order. Not just to feel how long a billion years really is, but to feel how strange and short and lucky this current moment, the one where something is finally around to look back and tell the story, actually is.